Hello guys. Today I'm going to show you uh, about the solution of Laplace equations in particularly in 8 equation solutions. So you already know, and you can see in mathematics books, in engineering mathematics books, about the heat equation solution and derivation of the Laplace equation for the heat equation. So it generally involves the Laplacian operator and a variable that varies with time. Mm, so I'm not going to describe all about that, but I'm going to show you how to code in MATLAB in order to see the way how heat diffuses into metal when there is sufficient temperature difference. So okay, so I have already coded here. I just wanted to explain it. So here I first clear the screen. Okay, so clear R, uh, clearing the screen and variables. Okay, so here these two elements do that, and after that I just form a matrix of 100 to 100. Okay, formation of matrix, two-dimensional matrix, actually two-dimensional matrix of size 100 to sorry to 100. Okay, this L is about the okay, so about the x-axis and about the y-axis. Okay, now I initialize a variable, a two-dimensional matrix variable. This is U is a two-dimensional matrix. U is a two-dimensional matrix, and I initialized it as zeros of rows L and adds L. So okay, you understand it. Okay, now just for iteration I initialize another variable for iteration. So okay, this is a boundary condition. You already know about this while solving the differential equations. These are boundary conditions. Okay, okay, now let's get started with the iteration. So I just do iteration for less than two. Okay, make it 2000. Okay, 2000 up to 2000, and okay, so yeah, I have to make iteration equals iteration is plus 1. Yeah, so now this increases the value of the iteration, and this selection of if is this particularly plots a particular value. This plots the value in the graph. Yeah, so this images as you what it does is it plots. Okay, if you want to know more about this, you can just search here help help images you, and it displays an image of this skate car. Okay, if you have some data in two-dimensional matrix, then it will plot that data in the different colors, and the intensity of the colors give the or the pixel value of the colors gives you the data, the magnitude of data. Okay, so it's no more complicated. And this color bar is about the range of colors. Okay, so how the magnitude changes with color. And this draw now will draw that images. Okay, and what is mode iteration 10 equals 0 means that you would that this would plot only after the iteration of 10. Okay, when 10 iteration would complete, then it will draw. Okay, so this is for all about plotting, only plotting. Okay, so now we are going to calculate the value of the u at a different location. Okay, so first of all, I just calculate the Laplace of u, that is del square u by del x square plus del 2y upon del y square. Okay, so this is lu, and after the each point, it's a row, and each point, this is its point. Okay, so from 2 to l minus 1 and 2 to s minus 1, each point of the u, that is new value of u, it is initialized as zeros, but now its value of the u's are updated to new value of u. Okay, so this is u, old u, and this is new u. Sorry, this is the Laplace u. Okay, and this would give you the new value of u, and that u would be plotted in every 10 iteration. Okay, now let's run it. You'll find something. Okay, so this is pretty interesting and fascinating. Okay, so you can see there are the hyperbolic curves. Okay, I just maximize it. Hyperbolic curves, isn't that? So this is how the heat transfer into the metal. Here, the boundary condition, we kept this point and this point as high, at temperature high, one of magnitude 1, and this temperature is 0. So the way heat diffuses into the metal is quite fascinating for us. If we go through analytical method by solving the differential equations using maybe separation of variables or any other method you study in mathematics, it will be very hard to visualize because it will give most complicated solutions in hyperbolic solutions, hyperbolic equation of sines and cosines. It will be very complicated to visualize, and you can see it just enter into equilibrium region, and where the total heat supplied and absorbed would be equal, or whatever you know about, you will do study. Okay, friends, thank you for watching this video, and you will enjoy very much, and it might helpful to you to do homeworks on differential equations, how to solve it in MATLAB. Okay, thank you for watching the video.